These are our pre-calc notes for 11.2. So we're looking at properties of limits now today. I know we touched on that a little bit in 11.1 with a lot of graph focus, and we're going to just work on skills that we have, little tricks that we can use to evaluate limits today. So the first thing that we talked about with our last lesson was just sometimes you can plug the number in. And that's what we see on this first one. When I have something like a linear function, 5x would be linear. I could just substitute 3 right away, and 5 times 3 is 15. So my limit is going to be 15. On the next one, the limit as x approaches 2 of 3. Well, 3 is just a constant, so it's just always going to equal 3. So we have an answer on this one too. Number 3, we can do the same kind of thing. 4x cubed plus 2x squared minus 6x plus 5. That is just a polynomial function. So as x approaches 3, we're not going to have any issues. What we really have to watch out for is dividing by 0. That's what we have to watch out for. So I can go ahead and evaluate this. And I could go through and substitute 3 for all my x's, but it's going to be a lot easier if I just do synthetic. So let's see, it goes cube, squared, x, and a constant. So I don't need to put any 0 placeholders in there. I write down my coefficients, bring down the 4. Remember, and then we're multiplying it and then adding. Let's see, 30, 42. And this number at the end is that value. So the limit as x approaches 3 of that polynomial function is just going to be 113. The next one, when I have fractions, I have to start worrying about zeros. But with a -3 minus 3 doesn't make a 0 in my denominator, so I'm fine. It might be easier to work with this in factored form. It might not be. So either way, you're fine. I thought it was easier working with something factored in class, but students kind of like just plugging it in. So -3 minus 3. Let's see. So we have 9 plus 3 minus 6. And you know what I'm screwing up here is once we start plugging in values, we don't write limit anymore, do we? So this is good. We're kind of calling attention to how we do this. So I start out with limit as x approaches -3 of this function, but then once I plug in the numbers, now I'm not writing limit anymore. So let's see, 9, and then my denominator is -6. So 6 over -6 is just a -1. So my limit's going to be -1. All right, on to the next one. So now we're looking at something where when I plug 3 in my denominator, 3 minus 3 is going to be an issue. I can't just plain substitute. So the first 4 we were able to just substitute. Now we can't do that. So my tip here is going to be factor. So when I factor my numerator, and because I'm not plugging a number in, I'm still rewriting all this limit notation. I have x minus 3 times x plus 2, and I also have a factor of x minus 3 in the denominator. And so I can simplify and say the limit as x approaches 3 of x plus 2. And now I have something that I can substitute into. So I'll do that. So 3 plus 2 is going to give me 5. On the next one, I have a similar issue. My denominator is x minus 2, so I can't find my limit as x approaches 2. So I need to factor my numerator. And what I'm really hoping is that I could have a factor of, let me kind of write this out, an x minus 2 in my numerator as well. So if I could divide this numerator by x minus 2, then I'd be able to cancel that out. So I'm looking for that common factor of x minus 2. So in order to figure that out, I'm going to use synthetic because I can't actually factor this polynomial. It's degree 4, there's 5 terms. I don't really have any tricks for that. So because I want to divide it by x minus 2, I'm going to do synthetic down here, and I'll be using a positive 2. So remember, we have to change that sign. And then we've got to write out our coefficients again. And it does factor evenly because I have the 0. And this would be that remaining polynomial. So if I started out with 4th degree, this is going to be 3rd. So that means I now have an x cubed. I don't have any x squared, but I have a plus x minus 1. So now that it's factored, I can go ahead and reduce and get rid of that factor of x minus 2. So I have the limit as x approaches 2 of x cubed plus x minus 1. And now that I have that simplified where I can substitute 2, I'm going to go ahead and do that. So 2 cubed plus 2 minus 1. Let's see, 8 plus 2 is 10 minus 1 is just 9. So the limit is going to equal 9. So on the first 4, we were able to just substitute. So we're kind of going over our strategies that we've used. And this is what we did yesterday also, right? We just substituted. On the next 2, in order to do something about getting rid of that denominator, we had to go ahead and factor. So that's another strategy. So sometimes you can substitute. If not, we have to try some stuff. And one of those things is going to be factoring. So because my denominator was going to be a 0 for both of these, I didn't have to worry about that in problem 4. But in 5 and 6, that number that x was approaching was going to make my denominator 0. I had to go ahead and factor. We're going to look at more strategies on the next page of our notes. So on 7, I am working with, let's see, I've got a square root here. And as x approaches 0, my denominator would just be 0. So what I really need is that x in my denominator to go away. But I can't factor this. This is weird. So what I am going to do is I am going to use a different strategy. And I'm going to multiply the top and bottom by the conjugate. So what I'm basically doing is I'm going to be like rationalizing the numerator instead. So I'm going to write multiply by conjugate. So we are basically rationalizing the numerator. So this is another strategy we can have. So because I have the square root minus 2, I'm going to multiply by that square root plus 2 on the top and bottom. So we know when we multiply and we do, I've got the same thing here and then minus and plus and a 2. So I'm going to scroll down to the bottom of my page really fast, make sure we understand how that works with x, because I know it's been a weird year. So if I multiply by x minus 5 times x plus 5, I know I get x squared minus 5 squared. So this is the strategy I'm using up there. I have those square roots and then I have the plus and minus 2. So I'm going to use that on my problem. And so now I'm going to have the limit as x approaches 0 of, if I have the square root of 4 plus x squared, that's just going to be a 4 plus x minus, and then 2 squared is just 4. And then my denominator will be the x times square root of 4 plus x, and then minus 2. All right. So in my numerator, the 4 minus 4 is just going to leave x. And then I have a factor of x in the top and bottom I can get rid of. So, and that's what I wanted, right? I needed that x in my denominator to go away because right now it would be a 0 times everything else. So now I have 1 over the square root of the quantity 4 plus x minus 2. And now that I'm at this point where I can actually substitute a 0 and not make a 0 in my denominator, I'm going to go ahead and do that. So now I'm going to substitute and have 1 over the square root of 4 plus 0 minus 2, which is 1 over the square root of, oh, this was not a minus, was it? This was a plus. See how we multiplied and it was a plus right here? I'm sure you were like trying to tell me that in your head all the way through this. So now I have, let's see, 1 over square root of 4 is 2 plus 2, so 1/4. So I knew I had a mistake when I got to the bottom of this was a 2 minus 2. Hopefully you caught that mistake earlier. All right, last problem. So in our last problem, we have this complex fraction here. So I've got fractions inside fractions. So my strategy on this one is going to be to do the math and basically just simplify and get one fraction. So let's see, I want to rewrite this so it's a little bit bigger. And I can barely even read it. 1 over x plus 5 minus 1/5 all over x. So I talked in my class how we had these like little baby denominators here. And I really need those baby denominators to go away. So I want to figure out what the LCD of those is. So my least common denominator of these two would have to have a 5 and an x plus 5. So that least common denominator is 5 times x plus 5. And then I'm going to multiply that in the top and bottom of the big fraction. And when I'm working with stuff like this, I try to always make these denominators for the big fractions obnoxiously big so I can kind of keep track of what's going on. So when I am multiplying this in the numerator, I'm multiplying this entire thing times both fractions. It's got to distribute to both. So when I multiply it by the first fraction, I have a factor of x plus 5 that's going to be in this denominator and one that would be in this numerator. So all I'm going to be left with, these are going to be gone, is that 5 times 1, which is just a 5, minus. And then when I multiply this times my 1/5, the 5's, I'll have a factor of 5 in the top and bottom, which I can get rid of. So I'll just have the 1 times the x plus 5, which is going to be an x plus 5. And notice I've left it in parentheses because I do have this minus sign here, and I'm going to have to make sure to distribute that. My denominator is just going to be x times 5 times x plus 5, but I do want to clean that up. I'm going to write it as 5x times x plus 5. All right, now I'm going to distribute that negative. So I have 5 minus x minus 5. So now the 5's are gone. And now I've got a negative x. And my whole goal here was to be able to get rid of this factor of x, and that's what I'm going to be able to do now. So now if I divide out that x from the top and bottom, or cancel it, or whatever kind of bad math slang we want to use, I'm just going to have negative 1 over 5 times x plus 5. So basically the x divided by x makes a 1, so it's gone. And then now that I have this to the point where I could actually substitute 0 and not get a 0 into my denominator, I'm going to do that. So I'll have negative 1 over 5 times 0 plus 5, which is negative 1 over 25, or negative 1/25. So we are all set with our notes. I know when you're looking through the textbook, they talk about all these properties of limits. I think they're really unnecessarily complicating this. Your Blitzer text does a great job of breaking things down into small pieces, but I think in this case, when they're breaking everything down into small pieces, it actually makes it more difficult. So remember the strategies we have. Our strategies are first to just substitute if we can. We could try factoring. We can try rationalizing our numerator instead by multiplying by a conjugate, and just simplifying and doing the math. So those are the strategies that we're working with today.